Okay, you guys, well, I'm back here now. I'm not able to get into my classroom right now, so I'm gonna film a different kind of a lesson for you guys. I don't know how well it's gonna work, but I'm trying different things. So I'm gonna try to work out a few problems. I'm gonna have the camera, I don't have a whiteboard to go on, so I'm gonna have you guys look over my shoulder as I actually solve some of the problems from homework 39, and then a couple that weren't even on homework 39, but will help you with homework number 40. So we'll do that. The worst part of it is, this is all you get to see of me. So pretty soon you're gonna just be seeing the problems, which I know is a big loss. Like, hey, at least when I'm doing the problems, you have something good to look at and the problems, but hey, what can I say? You're gonna just have to suck it up. I'm gonna try to get into my classroom so that you can get both me and the problems in the future, but today, this is what we gotta go with. Sorry. So come on over. I'm gonna do some exciting problems. I have them written out on these sheets of paper, and I'm gonna work them out with these pens. So here we go. There's our first problem. This number 11, you might recognize it from your homework. Here's how it goes. Here's what you do. First of all, this problem, I chose this one to do because it's kind of interesting, because what you can do is, see this 2 over x plus 3 over x, they are common denominators and they're on the same side of the equal sign. So you could do the problem with them split apart, but you can actually combine these into 2 over x plus 3 over x is just 5 over x, and make this thing become 3 over x plus 1 equals 5 over x, like that. Now, the next thing you would do which you do at all stages, whenever it's a fraction equal a fraction, like we have right here, it's possible to multiply by the least common multiple of the denominators. That's what we usually do. Now, x and x plus 1 don't have anything in common. They don't have an x, because x and x plus 1, they don't divide nicely into each other. Some people think that x plus 1 has an x, but it doesn't, because to have an x means it would multiply into it, or it would divide into it evenly, which it doesn't. So if I did want a common denominator, it would be x times x plus 1 is what I would use to times both sides, and then I multiply both sides by that. But here's another little trick, and this happens on a lot of the problems in tonight's homework, so pay attention to it. You can, if you do have just a fraction equal a fraction, nothing else stuck onto it, like a plus something or minus anything, as long as it's just a fraction equals a fraction, you can solve it by just cross multiplying. You get the same thing you would get if you multiplied by least common multiple of the denominators, but you can only do it when it's a fraction equal a fraction like this. So let me show you. So if you cross multiply, this guy times this guy, 3 times x is 3x, equals this guy times this guy is going to be 5 times x plus 1. That is the, boy, that doesn't look too good. Let me make it look nicer. But that's what you get. That's the same exact thing you would get if you multiply both sides by least common multiple of the denominator. Like, let me show you. It'd be the same thing as if I times both things by x times x plus 1. Notice, that's the least common multiple of the denominators. Look, the x plus 1 cancels with the x plus 1, and I get 3 times x is 3x. The x's could cancel right here, and I'll go get equals 5 times quantity x plus 1, just like I got here. So you could either multiply both sides by this to get there, or cross multiply, okay? Usually, I think it's easier to think of it as cross multiplying when you have a fraction equal a fraction, okay? So now we're gonna get 3x equals 5x plus 5. Oh my gosh, now it becomes a piece of cake. Can you believe it? Look at this, minus 5x from both sides. That's gonna give me minus 2x equals 5. I don't want minus 2x, I just want regular x. So I divide by negative 2, and I get x is negative 5/2, and cha-ching, there you go for the answer. That is number 11. Okay, now moving on. Here's problem number, let's see, what is it? That's right, Dan Marino, number 13. Okay, so here we go. Now this is a good example. Look at the denominators, s minus 6, s, and 2s. We need to create the smallest thing that contains all three of these guys. Well, here's the deal. It's gotta have an s, but it also has to have a 2s. Look, 2s contains s. So in order to contain these two guys, it's gonna have a 2s. If I leave out the 2, it doesn't have this guy. Leave out the s, doesn't have either one of these guys. And it also has to have an s minus 6. Now, do we already have an s minus 6? No, 2s is completely different, so I would have to times this by s minus 6, like that. Okay, so what I'm going to do now, I could make them all have this as the common denominator. But what's easier and better to do to solve the equation is to instead multiply both sides by this thing. This is what we talked about before. Times this guy by every single, now if you times it by this guy, you got to times it by this guy and this guy, everything. Even if they didn't have a denominator, even if it was just a number or something, you still would have to multiply it by all of that. Okay, here's what we get in the next step. We're going to get, watch this. This s minus 6 cancels with this s minus 6, and I get 2s times 3, which is 6s. Look, this guy cancels with this guy, then we have 3 times 2s, okay? Now, when I say equals, okay, when I get to the next term, this whole thing comes back. It's this guy times this guy now. This s cancels with one of these s's, and I get 4 times 2, which is 8 times s minus 6. So it's 8 times s minus 6, okay? Plus, now as soon as I hit the plus, as soon as I get to this guy, this whole thing comes back again. So it's going to be the entire 2s cancels with that entire 2s, and it just becomes 1 times s minus 6, which is s minus 6. Now I could put parentheses around that, but I don't have to. If this were a minus, I would need the parentheses because it would be minus a quantity. But since it's a plus, it doesn't really matter if I put the parentheses or not here. Okay, so the next step is to distribute that 8 right there. So I'm going to get 6s equals 8s minus 48 plus regular s minus 6. Now, this side will still simplify. 6s equals 8s plus one more s is 9s. Minus 48 and minus 6 is minus 54. Like that. Okay. Then I'm going to move the 9s over by minusing 9s from both sides. And I'm going to get negative 3s equals negative 54. I don't want negative 3s, I just want regular 3s. So I'm going to divide by negative 3, and I finally get s equals, okay, let's see, 3 goes into 5 once, 2 left over, bring down the 4, 24, 8, 18. Negative divided by negative is positive, so my answer is positive 18. By the way, these problems are worked out on the answer key that I sent out a little while ago. So you could follow along with these if you want to, because you do have a copy of the answer key for all of this. Okay, this guy. R over 2 minus 2 over R equals 5 over 6. So here's the deal. Look at the bottoms, 2, R, and 6. What's the smallest thing that goes into, no, I'm sorry. What is the least common multiple of those? The smallest thing that they all go evenly into. Well, 2 goes into 6, so we've got 6. We're gonna need a 6 at least, right? That contains a 2, and it contains a 6. It doesn't contain an R though. So what it's gonna have to be is 6R. I'm gonna have to times everything by 6R. everything. This, this, and this. So now it becomes, let's see, when I do this 2 cancels with this 6 and I get 3, 3r times r is, believe it or not, 3r squared. Ooh, we got a second degree equation here, okay? Now here, this r and this r cancel, and I get 6 times 2 is just regular 12 equals, the 6's cancel, and I get 5r. Notice, if you do it, if you pick something that all of these denominators go into, then every single time the denominators get wiped away and you have no more fractions in your equation. That's what's the best possible thing about this stuff. No more fractions. Everyone hates fractions. Now we can get rid of them. Yay. Now, since it's a second degree equation, I want one of the sides to be 0. So I'm going to do this. And I'm going to get 3r squared minus 5r minus 12 equals 0. Now I'm going to have to factor this. Now, remember, I'm going to give you a little refresher on factoring. 3r and r, right? That's the only way that 3r squared breaks up is 3r and r, because 3 is 3 times 1, right? R squared is r times r. Okay. Now 12 can be a bunch of different things. We can try, I can tell you 3 and here, 3 and 4 is not going to work because they would have a 3. That's not going to work. How about 4 and 3? 4 here, 3 here. That would give me 9 and 4, which gives me 5. Yes, that is the correct one. So I want the 3 there and the 4 there. And if I look at the oi's, look at the oi's now, 9r and 4r, right? We want them to subtract to be 5r, bigger one negative, which is 9. The bigger, notice the bigger oi is actually the smaller number. 3 is smaller than 4. So don't say bigger one's negative and think 4's the bigger one, so it's negative. No, look, this is represented by 9r and 4r, right? The bigger is the 9, so that's the one that has to be minus. And then we learned our little shortcut for solving from this point on. Whenever you got this times this equals 0, it's going to be r equals opposite of this over this. So negative 4/3, negative 4/3, and positive 3 over 1, or just positive 3. Those are my two potential solutions, actually. But none of those make the denominator 0. The only value that would make the denominator 0 for r here would be 0. If we happen to get r equals 0, that would end up being a bogus root. But we didn't get that. It's not a bogus root. These are the good roots. So there's the answers. Okay, great. Okay, this guy. This will be a good one to do. Some people, I think I noticed on homework, we're having a little trouble on these kind of problems. So pay attention to this. Look at the bottom, a squared, a, and this guy doesn't even have a denominator. So obviously a squared is the thing we need to times all these guys by. A squared, that's not that hard to see. We'll call it a squared over 1. Okay, so here's the nice thing. Look, when I times these guys by a squared, the a squareds cancel and I get just 5 equals, this a cancels with one of these a's, but not both, times 4, we get minus 4a, plus 1 times a squared is a squared because nothing cancels. So that was nice. We canceled these bottoms, got rid of the a squared out of the bottom, but we do have an a squared over here. So this is a second degree polynomial. Remember, we solved those by minusing our moving stuff over so that we have 0 on one of the sides. Okay, so I'm going to, this is already positive, my squared term's positive, so I'm going to leave it there, and I'm going to move the other side over, so I'm going to minus 5 from both sides here, and that's going to give me 0 equals a squared minus 4a minus 5. Okay, now I'm going to factor that, because I got 0 over there already. A squared, oh good, this is the easy kind of factor. I need two numbers that multiply to be 5 and subtract to be 4, like say 5 and 1. Different signs, bigger one minus. This one's minus, this one's plus. So I get A is opposite this over this, so positive 5 and negative 1, which are my potential solutions. But notice, the only things that would make these denominators 0 is if A happened to be 0. So these are good solutions, and those are them. Now, those are the problems from those problems were from yesterday's homework. I'm going to do a couple more now that that were actually not on yesterday's homework, but they're from yesterday's problems, and they're not going to be ones on your homework tonight, but they're going to be similar to some of them. So I thought I'd work a couple of these problems out for you. Okay, so here's the deal. I want to first thing I want to do is factor this guy. Notice it's a dog. It's a difference of squares. So it's W plus 1, W minus 1, right? Oh my gosh, look. This guy includes a W minus 1. We don't need another one. This guy doesn't have anything in the denominator. So clearly, W plus 1 times W minus 1 is the least common multiple of all the denominators. So that's what I'm going to times everything by here. W plus 1, W minus 1. Okay. So I'm going to times everything by it. Now, something really nice happens with the first step. Watch. This whole thing right here cancels with this whole thing right here, and you just get W plus 3. Nice. This goes away with this. Everything's great. Okay. Minus, be careful here. Minus this guy cancels with this guy. I still have a W plus 1, and I have to times it by 2W, and there's a minus out front, so it looks like this. I do need those parentheses for the W plus 1 equals, and here it's 1 times this, nothing cancels, so it's just W plus 1 times W minus 1, or you might just want to call this W squared minus 1, because that's what I'm going to do in the next step. If you wanted to just call it W squared minus 1 at that point, that would be all right. So what am I going to do in the next step? Call this W squared minus 1, basically FOIL it out, distribute the negative 2W. So W plus 3 minus 2W squared, plus, not plus, it's going to be minus 2W, because I'm distributing the minus 2W there, equals, okay, if I FOIL this out, I get W squared, then watch, minus 1W plus 1W, which cancels. This times this is minus 1. Sure enough, W squared minus 1, just like I said. Okay, now, what do we want? It's a second degree. Actually, no, let me combine this stuff together first. Let me take one more step. Negative 2W squared. Okay, 1W, and minus 2W is minus 1W, plus 3 equals this. So all I did from this step to this step is just combine those two. Now, this has a negative in front of it. That's bad. This is positive. We like that. So what we're going to do is we're going to move this whole side over here to get rid of that negative in front of our squared term. So I'm going to add W, 2W squared here. I'm going to add W, and I'm going to subtract 3. Notice every one of those things wipes out that side, so we get 0 is W squared plus 2W squared is 3W squared, okay? Plus W, minus 1 and minus 3 is minus 4. So look, second degree polynomial equals 0. So now I should be able to factor it. I'm hoping it factors 3W and W. That's the only way to get 3W squared. Let's do a 4 here and a 1 here. And notice that what the O's are. 3W and 4W, right? They subtract to, we need them to subtract to be 1, which they do. different signs, bigger one plus. So the 4 is plus, the 3 is minus, and then that means W is opposite this over this, so -4/3 and +1. Those are my, whoa, those are my potential solutions. And wait a minute, -4/3 is fine. What happens when I put 1? Oh my gosh, 1 minus 1 makes that denominator 0. Ooh, bad. And it would also make that denominator 0. It doesn't matter. If it makes any denominator 0, it's a bogus solution, right? So there was 2 potential solutions, but only 1 actual solution because this one did not make the denominator 0 where that one did. So you have to throw it out. Okay, one last problem. Okay, number 41. This is right amongst where the problems that you're going to be doing tonight's homework, although this one's not on it. Okay, remember what I said, that if you got a fraction equal a fraction, now notice that wouldn't work on this last problem here, because look, we have this guy, take away this guy equals this. It's not just a fraction equal a fraction, so this method would not work on a problem like this, but it will here, look, on this, because look, fraction equal fraction. When you have fraction equal fraction, you could get away with just cross multiplying. So that's what I'm going to do. I'm going to say, okay, let's call it, let me think. Let's call it x times x minus 4 equals 1, which I don't even have to put the 1 really, times x squared minus 16. It's just going to be x squared minus 16. So now distribute this, x squared minus 4x equals x squared minus 16. You guys stop it. Stop it. Okay?
I'm trying to make sure I get it right.
Minus x squared from both sides here. Minus 4x equals minus 16.
Looking good. All right.
Divide by -4.
Paper.
Okay, here.
Okay, there you go.
And then we get x equals 4. Which, oh my gosh, believe it or not, 4 squared is 16, minus 16 is 0. Wait a minute, our only potential solution turned out to be bogus. What does that mean? That means ain't got no soul, right? Yep. Ain't got no solution. Sorry. No solution. Sorry. That's how it goes sometimes. Okay, but that's okay. That's good information. It's good to know if an equation doesn't have a solution, right? What if you're a astronaut, and this is the equation that's going to bring you back from the moon? Wouldn't it be helpful to know that it doesn't have a solution before you left the Earth? I think so.
I think so.
Okay. And then finally, here's the homework. Look, it's only 10 problems. I gave you a real short one this time.
Sorry.
It's all right. It's going to be on their email too. But I gave you a real short one this time because it's I just want you to get a little more practice with these. Shouldn't take you too long. 10 problems. Page 677, 27, 29, 33, 34, 35, 36, 38, 40, 42, 43. There you go. Knock those out, and I'll see you guys next time.